Hey everyone, Praveen this side. I hope you guys are doing great. So today we are going to solve the problem minimize the height, which is a medium level problem. Okay, so let's read the description first. The description says given a positive integer k and an array ARR denoting heights of tower, you have to modify the height of each tower either by increasing or decreasing them by k only once. So this line is pretty self-explanatory, right? That we have been given positive integer k and an array which denotes the height of tower. Now we need to modify the height of each tower either by increasing the height or decreasing the height by k only once, right? Now find out what could be the possible minimum difference of the height of the shortest and longest towers after you have modified each tower. Now we need to find the minimum difference of height between the shortest and the longest tower after we modify each tower. That means we need to modify each tower, right? And there's a note point here saying that a slight modification of the problem can be found here. Okay, so if we solve this problem, then the slight modification of this problem we can find here. Okay, so we have understood the problem description. Now let's see the examples. So in the example 1, the input is given as k equals to 2 and the array is 1, 5, 8, 10. Okay. And the output is 5 because the array can be modified as 3, 3, 6, 8. That is, if we compare this array with this array, in the 1 they have incremented it by 2. Again for 5 they have incremented it by 2. For 8 it is decremented by 2 and for 10 it is decremented by 2. Okay. Now here the longest height is 8 and the shortest height is 3. So the difference between 8 minus 3 yields to 5. So our output is 5. And similarly for example 2 the k value is 3 and the array is given as 3, 9, 12, 16, 20. The explanation says the array can be modified as 6, 12, 9, 13, 17. That is, they have incremented 3 by 3, 9 by 3 and decremented 12 by minus 3, 16 by minus 3 and 20 by minus 3. After this modification, the minimum element is 6 and the maximum element is 17. So the difference between them is 11. Okay. Now we have understood example 1 and example 2 pretty clear. Now let's consider example 1 and try to find out few observations from it. Here we need to find the minimum difference of heights, that is the difference between long height and the short height, right? Now suppose we have been given an array 1, 5, 8, 10 and the k value is 4. Now what is the main observation that we can figure out from this array is that if our array is not sorted, first sort the array so the maximum element comes at the end and the minimum element comes at the start. Hopefully our array is sorted here and we can see the maximum element at the end and the minimum element at the start. Okay, now how can we find the minimum difference? If we simply decrement this by k and increment this by k, that is, suppose if the distance between 1 and 10 is 9. Now, how can we minimize this difference? If we bring 1 forward and 10 backwards, then we can minimize the difference, right? So, if we simply increment 1 by k and decrement 10 by k, and if we calculate the short height, then 1 plus 4 becomes 5, and for long height, it becomes 6, right? So, after modification, this point from here moves to this point, right? And this point from here move backwards, that is at 6. Now what will be the minimum difference? It is 6 minus 5 which becomes 1. So this way we can minimize our difference, right? Now can we simply increment the first position by k and decrement last position by k and find the minimum difference like this? No. Why? I'll draw this number line and get back here. Now here I have represented the array element as number line. Okay, so what mistake we were doing? We were simply incrementing 1 by k. So 1 comes to here, that is at 5. And decrementing last position by k, that is 10 from here comes here, okay, at position 6. Now we were finding the difference between longest height and the shortest height. Then we were finding the difference between longest height and the shortest height, where the shortest height is still shorter, right? But what happened to longest height? When we decremented it by k, right, it came to position 6. Now is it really the longest height? No, because 8 is already there which is longer than this, right, where 6 stands here and 8 stands here. Now what we were simply doing, we are taking the difference of 6 and 5, right? But is it true? No, because we should be taking the difference of 8 and 5, because the height we need to find is the longest height and the shortest height, where 6 no more stands as the longest height, right? So what we were assuming was completely false, right? Now what should we be doing to find the difference of minimum heights? Let's see that. Now, what could be the initial minimum height for us? What we have assumed in the start, the difference between last element and the first element could be the initial minimum height for us, right? So, we'll take the difference of 10 minus 1, that is 9. And why we are so confident for this? Because even if we take plus k on both the sides or minus k on both the sides and take the difference, still the initial minimum height could be 9, right? Now, what processing should we be doing to minimize this height as minimum as possible? Now, suppose we are at index 2 and we need to find the longest height and the shortest height, right? So that we can take the difference of this and minimize our height as minimum as possible. When we are at this element, what should be the modification with the previous elements? We should be incrementing them, right? So that we can minimize the height. And similarly, when we are at this point, what should be the treatment of array elements after this point? We should decrement it, right? So why are we incrementing this part and decrementing this part? So that we can minimize the height as minimum as possible. So we need to increment these heights by k and decrement these heights by k so that we can minimize them. Now for this point, what can be the long height? It could be either this or either this. This we understood because since it is the last element, this could be the potential maximum height. But how are we saying that this could be the longest height? Because for this element, we are decrementing its height. But for this element, we are incrementing its height. Are you getting it? If you represent this modification in number line, it looks like 1 plus k will be here. Then followed by 5 plus k. Okay. Now we are decrementing 8 by k, right? So there's no chance that it will increment like this. There will be a dip from here. That is 8 minus k would be somewhere here and then 10 minus k. Here, these 2 points can be the longest height for this point. Why? 10 minus k will always be greater than 8 minus k, right? Because if we cancel out minus k from both the sides, 10 will always be greater than 8. So, whatever the k value may be, 10 will always be greater than 8. Now, for this point, how can we say 5 plus k is greater than 8 minus k? Because here we are doing addition of k for 5 and for 8 we are doing the subtraction of k. So there could be high chance that this equation surpasses this equation, right? So that's why we are considering 5 plus k can be one of the maximum heights for 8 minus k. Okay, let me move this equation here. So the longest height could be the maximum of either the n minus 1 element that we are having, that is the last element, or the previous index that we are standing at. Because if you are standing at this index, the previous index element could be one of the maximum heights that we saw in this number line. Okay, let me clean this up. Now for this point, what could be the short height? It could be either the starting element or the element itself. Now here it is self-explanatory that why starting element could be the shortest height. But why this could also be the shortest height? Because again, if you see the number line, from this point we are decrementing the array, right? So this could also be one of the minimum height. So we'll take the minimum of this height and this height. So the minimum height will be 0th index and the ith index that we are standing at. Now at the long height equation, at n minus 1 we are decrementing it by k, right? And at I minus 1 we are incrementing it by k. And similarly for the short height, at 0th index we are incrementing it by k, and at the ith index we are decrementing it by k to find the minimum height. So after we get the long height and short height, we can minimize our minimum height by solving this equation. So this is the main thing that we needed to figure it out, right? Now here I have just written the observation, but I didn't do the dry run because I want you guys to dry run. Because if I do the example dry run, I will understand. But if you do the example dry run, you will understand it better than what I explained to you. Okay. So with these observations, let's get into code. So here's the code in C++, although the logic remains same. So the function name is get minimum difference and the parameters passed are k and the array. So firstly, I have taken the array size and I have sorted the array because the array could be either sorted or unsorted. So for handling it in our side, I have sorted the array. Now I have considered the initial minimum height, that is the last element and the starting element. Then after, I'm starting the loop from I minus 1 till n. Now why I am starting the loop from I minus 1? Because we are checking for the previous index also right here. If we if we start the if we start the I from 0 and if we submit it here, then 0 minus 1 will be minus 1. But minus 1 index doesn't exist. That's why I am starting I from minus 1. Then inside I am finding the short height, that is the minimum of the starting index with k and the current index with minus k, and the long height will be the last element with minus k and the previous index of the index that we are standing at with plus k. And after we find the shorthand and long height, we minimize the minimum height by finding the difference between the previous minimum height or the current potential minimum height that we found. Okay, and after we execute this loop, we simply return the minimum height. So the code is very simple, but the observations we gathered is very tricky, right? Now, what could be the time complexity for this approach? Here, we are sorting the array. So for sorting, it takes O of n log n, where n is size of array. Okay. And here, we are running a loop till n. So for this, it's O of n. So the overall time complexity for us is O of n log n. And what is the space complexity for this? Since we have just used the variables here, so the space complexity will be O of 1. So this was the problem, guys. I hope you guys like this video. If you have liked this video, please like, share and subscribe. And if you have any doubt at any point, please comment it down. I'll try to respond to it as quickly as possible. And if you have any feedback for my teaching, please comment it down too, so that I can improve on that. So meet you guys tomorrow solving any other kind of problem. Till then, stay safe, stay happy, and peace.